All right, so our first type of exponential equation that we're going to be solving starts off with a fact that states that if you have b to the x equal to b to the y, then it must be true that x equals y. If we consider a case where we have 2 to the third, it cannot equal 2 to the fourth. So as long as these base numbers are equal, our exponents have to be equal to one another. So whenever we're solving an exponential equation, if we can find a way to set these two base numbers equal, we can immediately drop the bases and set the exponents equal to one another. So let's try an example. We have 3 to the 2x plus 5 equal to 81. Notice that 3 and 81 are not equal bases. But if we look at 81 and break it down with its prime factorization, we can rewrite 81 as 9 times 9 and 9 as 3 times 3, giving us 3 times 3 times 3 times 3, or 3 to the fourth power. This allows us to rewrite our problem as 3 to the 2x plus 5 equals 3 to the fourth. And now that we have equal bases, we can drop the bases and just set the exponents equal to one another, giving us 2x plus 5 equals 4. And now we can just solve for x. We'll subtract 5 from each side to get 2x equals -1. And then dividing each side by 2 gives us x equals -1/2. And you can always do a quick check with this by taking this value, plugging it back into x in the original equation. And when you do, the left side will simplify to give you 81, which checks out to equal the right side. At this point, go ahead and take a moment to pause the video and try to solve 16 to the x minus 2 is equal to 64. Okay, so going through this, we can rewrite this with a base of 4, as 16 is the same thing as 4 times 4, or 4 squared, and 64 is the same thing as 16 times 4, and again 16 breaks down into 4 times 4, giving us 4 cubed. If you chose to break these down into 2 to the fourth and 2 to the sixth, that will also work. But if we just use the example I just mentioned of 4 squared and 4 cubed, we'll get 4 squared to the x minus 2 is equal to 4 cubed. At this point, we have an exponent being raised to another exponent. Whenever you raise an exponent to another exponent, you multiply them together, meaning we're going to distribute this 2, leaving us with 4 to the 2x minus 4 equals 4 cubed. And at this point, our bases are now equal. The exponents are no longer attached to each of them, so we can now drop the bases as we did in the previous problem, giving us 2x minus 4 equals 3. And now solving for x, we'll add 4 to each side to get 2x equals 7. Dividing each side by 2 to get our x alone gives us x equals 7/2. And just like before, we could take this value, plug it into x in the original equation, and this entire left side will simplify to give us 64, just as the right side.